When a strategic transport aircraft design concept from an academic paper sparks such widespread collective discussion among military enthusiasts and media online, what technological breakthroughs and strategic considerations lie behind it, prompting foreign media to speculate that the Eastern powers' development in the giant transport aircraft field may already be a foregone conclusion. Within the global aviation transport equipment spectrum, strategic transport aircraft occupy the pinnacle of the pyramid. Such aircraft typically require a maximum takeoff weight exceeding 400 tons and an actual payload capacity surpassing 100 tons to undertake intercontinental deployment missions for main battle tanks or heavy missile launchers. Currently, only the United States and Russia possess truly mature equipment systems in this domain. The US C-5M Super Galaxy transport aircraft boasts a maximum takeoff weight of 418 tons and can carry 122 tons of cargo, over 9,000 kilometers, a range metric that stands out among comparable models. Russia's aerospace forces rely on the An-124 Ruslan transport aircraft as the backbone of their strategic deployment capabilities. This model has a maximum takeoff weight of 405 tons, while its maximum payload capacity reaches approximately 150 tons. Its full load range is only slightly over 4,000 kilometers, significantly shorter than that of the American aircraft. In terms of numbers, the U.S. Air Force currently operates over 40 C-5 series aircraft, while Russia maintains more than 20 An-124 series aircraft, both sustaining substantial fleet sizes. Shifting focus to the sub-segment of heavy transport aircraft reveals a different competitive landscape. China's Y-20 series, Russia's Ilyushin Il-76 series, and the U.S. C-17 series once formed a three-way stalemate. However, the C-17 production line ceased operations as early as 2015. The Y-20B variant, equipped with WS-20 turbofan engines, boasts a maximum takeoff weight exceeding 220 tons and a payload capacity of 66 tons. With over 100 units currently in service, it stands as one of the few large transport aircraft still in mass production with substantial carrying capacity. While this number still lags behind the vast U.S. transport fleet, it significantly surpasses the scale of Russia's large transport aircraft within its aerospace forces. However, a distinct performance gap exists between large transport aircraft and strategic transport aircraft. The former cannot fully transport certain oversized or overweight specialized equipment, and this gap is precisely the core reason for the external focus on the new strategic transport aircraft project. A recently discussed academic paper outlines a design concept similar to the C-5M but with optimized details. According to data disclosed in the paper, this model features a design empty weight of 246 tons, a design payload capacity of 120 tons, a maximum takeoff weight of 468 tons, and a design fuel capacity of 102 tons. These parameters indicate its transport capability approaches that of the C-5M, while its substantial fuel capacity ensures intercontinental range requirements. Some foreign media outlets speculate that this project may be the long-rumored Y-40, whose overall specifications have surpassed those of current US and Russian models. Others suggest that following China's aviation industry naming conventions, the new strategic transport aircraft is more likely to adopt the Y-30 designation, forming a progressive sequence with the Y-8, Y-9, Y-20, and Y-30. Cargo hold dimensions represent another critical metric for evaluating strategic transport aircraft performance. Reports indicate this design features a cargo hold height of 5 meters, a length exceeding 21 meters, and a cargo area surpassing 170 square meters. This configuration enables simultaneous transport of multiple main battle tanks or larger missile launchers. In comparison, the C-5M excels with its exceptionally long cargo hold of 43.8 meters, ideal for transporting elongated equipment. The An-124, meanwhile, is renowned for its cargo hold width of 6.4 meters, allowing it to carry wider specialized cargo. The emphasis on width and height in the new design reflects the designer's anticipation of evolving dimensions in modern Army heavy equipment, particularly long-range air defense systems and ballistic missile launchers, which often feature substantial external profiles. Engine technology has always been the key factor constraining the development of strategic transport aircraft. The WS-20 engines currently used on the Y-20B provide approximately 16 tons of thrust per unit, which is sufficient for a 220-ton aircraft. However, to lift a strategic transport aircraft weighing over 460 tons, high bypass ratio turbofan engines with at least 25 tons of thrust per unit are required. The CF6-80C2 engines powering the US C-5M deliver approximately 23 tons of thrust each, while the D-180 engines on the N-124 also operate in the 23-ton range. Reports indicate China has made progress in developing large bypass ratio engines for commercial use, with the Changjiang 2000 engine achieving thrust test data of 35.2 tons. If comparable technology could be applied to military variants, 4 engines could deliver over 140 tons of total thrust, sufficient to support aircraft exceeding 400 tons. However, transitioning from civil engine validation to military installation involves complex processes, like reliability testing and environmental adaptation assessments, often taking longer than anticipated. Whether the new transport aircraft should possess field-airfield takeoff and landing capabilities is another noteworthy technical consideration. Analysis indicates the design accounts for full-load takeoff from 2,600-meter-long rudimentary runways and altitude-adjusted operations at 4,000-meter plateau airports. This emphasis on short takeoff, landing, STOL, and high-altitude, high-temperature performance aligns closely with the design philosophy of the US C-17, differing from the C-5 and N-124 models primarily reliant on large-scale base operations. If this design approach is accurate, it signifies that the new strategic transport aircraft could not only execute rear-to-rear strategic transport, but also conduct direct resupply closer to the front lines, significantly enhancing its support role within the combat system. Regarding material application, increased use of advanced composites helps reduce structural weight. Some reports indicate the design incorporates silicon carbide fiber composites, which offer approximately 15% weight reduction and 30% strength improvement over traditional metals. With an empty weight controlled at 246 tons for a maximum takeoff weight of 468 tons, the aircraft demonstrates excellent structural efficiency. A lower empty weight means more weight can be allocated to fuel and cargo, thereby enhancing economic efficiency and mission flexibility. Looking back at the history of global aviation development, many aircraft models that eventually entered production underwent lengthy pre-research and concept validation phases. Between published academic papers and the actual manufacturing of prototypes, significant uncertainties remain. China's aviation industry, starting with the Y-40, has spent over a decade completing the development and mass production of large transport aircraft, accumulating comprehensive experience across the entire process, design, manufacturing, flight testing, and modification. This expertise is invaluable for subsequent development of even larger aircraft models. According to some foreign media projections, if the project progresses smoothly, the prototype could debut around 2027. Following several years of flight testing, operational capability is expected to be gradually established after 2030. On a broader level, the development of strategic transport aircraft is intrinsically linked to the advancement of the entire defense industrial system. It represents not merely an aircraft, but a nation's comprehensive capabilities across multiple domains including aerodynamics, materials science, aeropropulsion, avionics systems, and precision manufacturing. Globally, only a handful of countries and regions possess the capability to independently develop 200-ton class transport aircraft, while those capable of tackling 400-ton class strategic transport aircraft are even rarer. From this perspective, the paper circulating online, regardless of whether it corresponds to an actual project, at least indicates that relevant research institutions have conducted in-depth exploration in this field and developed proposals with significant technical depth. For observers tracking aviation equipment development, this heated discussion also offers an opportunity to re-examine the role of strategic transport aircraft within modern military systems. It serves both as a force projection tool and a symbol of strategic deterrence, its flight paths often extending political and military influence. Once the buzz around this paper subsides, the real question worth pondering is, when will the parameters and concepts outlined on paper transform into the actual steel giant standing at the end of the runway?